Hello everyone, I am Sudarshan. My trainer name is Surendra sir. Today we are going to discuss about the topic called as searching algorithms. So why do we use searching algorithm? So the array, like in the topic of the array, we would be using to access the elements and the finding that if the element is presented in the array or not. So they are the most two common searching algorithms which would be used, and they are linear search and binary search. So, what is the use of this searching? So, by using linear search, we are able to find the element throughout the array by using a single for loop, and it goes from 0 to n minus 1 of the array. So, let us take an example of the linear search. So, I wanted to find the element 25. Through the linear search, we would be going from 0 to n minus 1 by a single loop. We would be first iterating through 0 and checking for array of I, where we would be using in the for loop if array of I equals to target, we would be returning the array of I element, else we would return minus 1 if the element is not present in the array. So let us iterate through it. I want my target element is 25. So we would be checking for is 24 equals to 25, and it would be not matched, and array would be I will be updated to 1, and so on. It would be going 1 2 3 4. So at array of 4, my value would be 25, so the target would be matched, and array of I would be returning 2, and it would return, and it can be manageable by 2. By returning of, we can be accessing it through the return of I, array of I, or return true. It returns whether that the element is present in the array or not. And the time complexity for this would be, at the worst situation, would be big of n, because we are iterating throughout the array, and it could be gone for the end of the array. Next, we would be discussing about the binary search. So one of the key aspect of the binary search is to the array should be always sorted, and binary search would be only work when the array is sorted. So let us take an example of sorted array. And my target value is 6. I wanted to find the 6 value. So what would be doing in the binary search is that we would be finding a midpoint, and we would be searching from the left side of the array and from the right side of the array. So let us declare a low point where low equal to 0, and high point equal to n array of n minus n, n minus 1. So it would be depend upon the array size, and I would be iterating a while loop where low is less than or equal to high, and I would be declaring a midpoint. So it goes as L plus high by 2. So my low equal to this, and my high is this. So while we are doing the indices, so while we want to find the midpoint, it would go as 0 plus 7 by 2, and it would be coming as 4. So my midpoint would be this. So in this, we would be doing as, if array of mid equals to target, we can return the ith position, or if else if array of mid is less than the target. So here we can see that my the target which I have set is 6, and it is less than the array of mid is less than the 6. So I can update my mid to +1. Sorry, I can update my low equals to mid +1. So it would, the low would be updated here, and high would be here. And if again the while loop low is less than high, so again the binary would be going on, and the last condition, else condition, is else if array of mid is greater than target, if the target value is belong this side, my high would be updated as mid -1. If any of the cases would be not satisfied, the default value would be returned as -1. So here we are, when we are searching through it, we almost all reduce the effort to finding the value. So, and again in that again half values we have reduced the finding value. So the time complexity would be going as big of log n. This is the time complexity. Thank you.